Hi, let me tell you about another great Manning book, Machine Learning on Tabular Data, Using Gradient Boosting and Deep Learning, written by Mark Ryan and Luca Masserone.
Tabular data, commonly found in spreadsheets, CSV files, and databases, is a cornerstone of our daily lives and a key resource for training machine learning and deep learning models. Utilizing this data effectively can solve practical problems in various fields, such as finance and banking, healthcare, e-commerce, telecommunications, and manufacturing. This book shows you how to choose the right modeling approach for tabular data problems, introducing two main methods: machine learning and deep learning. We also discuss why tabular data requires a different approach than other data types, such as images and text. Tabular data, organized in rows and columns, differs from other data types like images, videos, audio, text, and JSON data. While these non-tabular data types have been used to train deep learning models, deep learning has not been widely applied to tabular data. We will explore the reasons behind this and when it is appropriate to use deep learning with tabular data. Machine learning and deep learning are two distinct approaches to tabular data modeling. Machine learning involves feature engineering, identifying and extracting the most relevant information from the data, and converting it into a suitable format for the model. However, deep learning, inspired by how a biological brain is structured, can learn useful representations directly from the data and map them to predictions. Such capability, called representational learning, allows deep learning to process data internally and automatically for problem solving. This means deep learning models can automatically discover intricate patterns and dependencies in the data that may not be apparent through manual feature engineering. In contrast, classical machine learning models focus more on manual data processing and other ways to embed subject matter expertise into the model. Using deep learning with tabular data is a controversial topic in data science. Some practitioners believe that gradient boosting techniques are sufficient and that deep learning is unnecessary. In contrast, others argue that deep learning outperforms gradient boosting in some tabular data applications. This text explores gradient boosting and deep learning for tabular data, guiding when to use each approach. Tabular data differs from other data types because it is structured in rows and columns, unlike unstructured data like audio, video, images, and text. Deep learning has revolutionized the process of transforming unstructured data into a structured format for predictive models. However, deep learning has faced challenges when applied to tabular data, primarily because tabular data is dispersed across private databases with varying rules and structures. Tabular datasets are difficult to access and contain a wide range of information, making it challenging to apply pre-trained deep learning solutions. Unlike images and text, where deep learning models can be easily shared and adapted, tabular problems currently cannot rely on transfer learning. This has limited the success of deep learning models for tabular data. However, both machine and deep learning can be used to solve tabular data problems, and deep learning can be more effective when working on very large datasets, where it can learn better representations from the data. In addition, we are confident that deep learning will become more important even for standard tabular data problems, as researchers test new architectures on realistic tabular data.
Get this book at manning.com